Okay, so far we have looked at regression, and we said that the reason why we do perform regression is because we'd like to establish the relationship between the variable of your choice, your response variable, or your outcome variable, or your dependent variable, based on other variables that we wish to explain with it, no? And we said that dalawang purpose yan, it's either describe or explain, and also to forecast or predict. Gusto natin ma-predict yung dependent variable natin based on the values of your independent variable natin. And we said dalawang sa regression, guys, you have the simple regression, okay? Sana na-import nyo lang, guys, yung wage, no? Simple regression, simple linear regression, if you have one predictor, one independent variable, and then we have multiple linear regression if you have several independent variables. Okay, the method used in determining the parameters for regression is called your ordinary least squares. Okay, so sorry guys, I'll use para mas mabilis tayo. I'll use the one we okay, and then whatever we finish today, guys, I'll also send the R file. But I suggest that you follow along. No? Okay. Sabi natin, guys, na ang ginagamit na method in order to do linear regression is ordinary least squares. Okay, ano ba yung ordinary least squares? Okay, the squares here, guys, refer to your errors squared errors. Okay, di ba pag nag-generate tayo ng regression model, you have your actual value ng dependent variable nyo, tapos you have your predicted value, then you get the residual, the difference between the actual and the predicted value, and then you square that. So the line of best fit is the one where you have the least, yung pinakamaliit na errors squared, or deviation squared, or residuals squared. That's the basis for your regression line. And that line of best fit, no? We call it the line of best fit. Okay, the line of best fit, it's a unique line. Okay, ibig sabihin, you have only one line that you have only one unique regression line. So given your parameters, given your predictors, you can only have one line of best fit. Okay, so that's your regression line, and as I said, that's determined using the ordinary least squares method, or method of least squares. Okay, so we were looking at this wage variable, no? Sabi natin, ang laman nito 8 variables. Tapos yung ano natin, yung dependent variable natin, we were trying to model hourly wage. Okay, using these variables. Initially, ang ginawa natin, yung education lang, yung regressor natin, or the predictor. So that was our model 1. Okay, so let's ayusin ko lang to, no? That was our model 1. Guys, medyo my throat is acting up. Okay, so ito yung model 1 natin, di ba? Okay, how do we perform that model? How do we do that model? In R, we use the LM function. Okay, LM function, so that's linear model. And then we define first our dependent variable, hourly wage, regressed on education. Then we define what data is that's coming from. Data is equal to wage. Kaya we don't have to identify here wage, dollar, hourly wage, no? Kasi ang syntax naman niya, dito natin i-define kung ano yung data kung saan siya nanggaling. Okay, and then let's run this. Okay, so yung model 1 na naka-parenthesis, ibibigay lang sa atin yung coefficients. So medyo hindi comprehensive yung makikita natin dyan, kaya we do the summary. Okay, very quick review, guys. Ang major dalawang parts to. Unang-una yung overall goodness of fit natin nasa ilalim. Okay, and then ito yung individual t-test natin. Okay, so yung sa overall goodness of fit natin, sabi natin degree of freedom 1 is 1 kasi iisa lang naman yung dependent variable natin. Degree of freedom 2 is 524 and that was obtained by n minus k minus 1 or n minus q minus 1, di ba? Di ba? N minus k minus 1 or others call it n minus q minus 1. Where n or q refers to your predictors, kung ilang predictors. N is a number of observations. K is a number of predictors. 1 is to account for the intercept kasi ini-estimate the intercept. Okay, and estimating the intercept means that you also lose 1 degree of freedom. So 526 observations minus K, which is just 1 kasi education lang yon, and minus 1, so that's 524. So that's where we get this 524. And then the p-value, no? So sabi natin, inference, statistical test to, and this is the statistical value, and you have the null hypothesis, no? Ang null hypothesis natin dito is beta null is equal to beta 1 is equal to 0. So lahat ng mga parameters kasama si intercept ini-equate sa 0. And then we say that based on the p-value, which is less than 0.05, sabi natin, when the p is low, the null must go, no? So we are rejecting the null hypothesis that all the parameters are equal to 0. We say that there's statistical reason to believe that at least one of this, B null is equal to B1 is equal to 0. At least one of them is non-zero. We're not saying that everything is not equal to 0. We're just saying that at least one of them is not equal to 0. Okay, then we define yung R squared natin, 16.48. It's the proportion of the variability of your dependent variable, in this case, hourly wage, that can be explained by our model. In this case, the lone independent variable, HR wage. So sabi natin, yung model natin consisting of education can account for 16.48% of the variability of your dependent variable. Yung 83+% na yan, ibig sabihin, that could be explained maybe by other variables. Pero yung model natin, 16.48% lang. Okay, and then we looked at the individual t-test. Okay, t-test kasi t-statistic yung ginagamit dito. And dito dalawa yung result na nakikita natin, ano? Yung intercept at saka yung independent variable natin. So how do we define this? Assuming yung intercept is significant, ang ibig sabihin nitong negative 9.048 na to, this is the value of your dependent variable when your independent variable is equal to 0. So ang ibig sabihin nito, negative 0.9, that's the average hourly wage, kasi HR wage yung ano natin, yung dependent variable, when for a person who has 0 years of education. Okay? That clear, guys? Clear ba yung explanation ng intercept na yan? Paki-chat nga please kung clear siya or okay, clear? Okay, thank you. Okay, thank you. All right. So unfortunately guys, yung intercept natin, it's not significant, no? Sabi natin magiging significant yan kung less than 0.05. because that's the usual na level of significance na ginagamit. Pero sabi natin, yung intercept, kahit na hindi siya significant, sinasama pa rin natin siya sa model natin. Unlike the independent variables, pag hindi significant yung independent variable, hindi natin isasama yan sa sa model natin. Okay, then going here to education, the estimate is 0.54. The p-value is less than 0.05, no? By the way, ang null hypothesis dito sa intercept is b null is equal to 0. So ang answer dito, we fail to reject the null hypothesis that b null is equal to 0. Ang implication nun, pwedeng 0 yung b null natin. Ito naman, for education, ang null hypothesis natin, b1 is equal to 0. Inference natin, conclusion natin, we reject that null hypothesis that b1 is equal to 0. There's strong statistical reason to believe that b1 is a value other than 0. Hindi siya 0. Okay. So ito yung estimate natin ng education, 0.54. Anong ibig sabihin nito? When you interpret this, ang sasabihin natin, for every 1 year increase in education. Bakit year? Titingnan natin dimension ng variable natin. Kung year yan, so year ang gagamitin natin. Kung dollars yan o pesos yan, dapat peso din ang pag-interpret natin. So for every 1 year increase in education, there's a corresponding $0.54. Okay, on the average, there's a corresponding $0.54 increase in hourly wage. Okay? So kung nag-increase education, mag-i-increase din si hourly wage kasi positive yung relationship nila. Positive yung beta 1 natin. Okay? And it's statistically significant, no? Kasi nga sabi natin, the p-value is less than 0.05. When the p is low relative to the level of significance, the null must go. The null must be rejected. Okay. All right, then we said, guys, that yung equation natin ito, no? Hourly wage is equal to the intercept plus the slope times education. Okay, plus epsilon. Ano to? Error term. Kasi hindi eksaktong nagmamatch yung actual natin kaysa dun sa predicted natin. However, when we already put here the hat, no, hourly wage hat, ibig sabihin, computed na to. Ibig sabihin, predicted value to. That's why you don't have the epsilon here. Kasi kunyari, what's the predicted value of a person with 11 years of education? E di palitan lang natin 11 to, and then what the result will be, yung predicted hourly wage natin. Okay? Kaya wala siyang error term dito, epsilon. Ito, hindi pa natin pinipredict, no? Hindi pa natin pinapalitan si independent variable natin. Okay? All right. So that's our equation. Then we looked at yung SST, SSE, SSR natin. No? Sabi natin, these are 3 very important measures. Si SST, that's the total variation of your of the dependent variable compared to the average. No? Kasi ano ba yung variation, di ba? Ang sabi natin ng variation or standard deviation, ang standard natin yung average. So we're comparing the actual hourly wage with our standard. In this case, the standard is the mean. So ang squared deviation yan is called your SST total. And then what happened? Nag-regress tayo, gumawa tayo ng model. No? Nung gumawa tayo ng model, ito yung nakuha natin, SSR, sum of the squares regression. And it's defined by yung model value natin minus the mean, okay, squared. Ibig sabihin yan, nag-improve yung ano natin, yung, mukhang mali itong formula natin, no? May kulang pa. Dapat may parenthesis to. Tapos may parenthesis dito. Okay. It's everything that is squared. Sorry about that. May kulang din dito. No? Oops. Wala na to. Sorry ha. Tama ba? Sobra to. Okay. All right. So SST, sum of the squares total. Okay, that's the total variation of your dependent variable. Tapos si SSR, SSR, sum of the squares regression. So we improved on our benchmark on our standard model by doing the regression. So yung difference niya, okay, so that's the improvement of your model. Ang tawag natin dyan, sum of the squares of your regression. Tapos yung hindi natin na model, that's sum of the squares of your error terms or residual. So that's the difference between your actual value minus your predicted value and then squared. Kaya nga, squares, no? Sum of the squares. Okay? So we did this last time and we learned that si SST, run nga natin to very quickly. Ang total variability, variation ng dependent variable natin is 7160. By performing linear regression, we were able to explain 1179 of it. No? Ang natira, 5980. Okay? So that's why, ang tawag natin dun sa R squared, coefficient of determination, yung proportion ng variability ng na total natin that can be explained. So that's why it's 1179 divided by 7160, that's 16.48%. No? Okay, so yun ang kayang i-explain ng education on the variability of your your dependent variable hourly wage. Okay, so yung model 1 guys, yung ginawa natin na LM kanina, it contains several objects, no? So, clinic ko itong model 1, marami siyang laman, no? Hindi lang siya data frame. It's a list. So, andito si coefficients, dalawa daw laman, which is your intercept and your slope. Andyan yung residuals, andyan yung mga fitted values, etc. So, it contains several elements, yung mod 1 natin. So, hindi lang siya data about the prediction. Okay, so let's go back here. Okay, then we can also compute for the confidence interval. Let's run this. Yung confidence interval natin, tingnan nyo guys, intercept, no? Okay, negative 2.25, okay, 97.5. This is the 95% interval. So this is 2.5% to the left, 97.5% from the left to the right. Ang nasa gitna niya, 95%. Notice na, is it possible for 0 to be the value of your intercept? Yes. Kasi it ranges from negative 2.25 hanggang 0.44. So, tingnan nyo guys, in between this, tatamaan si 0. So, that's why sabi natin, yung hypothesis natin na B sub 0 is equal to 0, possible ba naging B sub 0 is equal to 0? Yes. Kaya nga rini-reject natin yung hypothesis na yun na B sub 0 is equal to 0. And that was seen in the p-value. No? Okay, how about education? Between 0.44 and 0.64, impossible na tatamaan niya si 0. Okay, that's why we rejected the null hypothesis that B1 is equal to 0. Okay, so here guys, you can see here the APA format to write the result of your regression. Mas titingnan natin guys yung multiple, no? Kasi ito simple lang to. Okay, so we have done this last time. Okay, punta na tayo guys sa ito pala, no? Ito muna. So you just don't stop at doing the model, doing the LM function. Kailangan, remember, we're coming from several assumptions. We have to test if we violated the assumptions. And how do we do that? We do that, guys, by dito. Okay, here. We will plot the residuals. So residuals yung tinitingnan natin, no? So in this chunk, par, that's partition, yung rows natin, 2 by 2, 2 rows, 2 columns, and then i-plot natin yung model 1. So this will give us these diagrams. Ito. Okay, so itong diagrams na to, okay, residuals versus fitted, tinitingnan natin kung ito, this will tell us kung linear yung yung variables of interest natin, kung linear yung relationship nila. Okay, it will tell us also something about homoscedasticity. It will tell us also about influential points. So maraming pinapakita ito. No? Ito naman guys, this will tell us if our residuals are normally distributed, yung normal quantile plot. Then this one will tell us kung homoscedastic na or heteroscedastic yung error terms natin. As much as possible, we want our error terms to be homoscedastic. Okay, and then the last one, this will tell us of influence points, no? Using the Cook's distance. Actually guys, lima tong diagram na to kaso hindi napapakita yung isa. But I'll tell you how to show it. Okay. Okay, this is another way to plot those diagrams, guys. Auto plot, no? But you have to link it with GG45. Okay. So, okay, let's go here. Number 1. So, tingnan natin guys very quickly yung ano natin, yung mga tinetest natin, assumptions natin. The first plot, kanina guys, yung par MF row natin 2x2. So, binigay sa atin 2x2 na plots. No, ito pwedeng isa lang. So, plot mod 1, 1. This is the first plot. So, what does this show us? The first one is used to check the linear relationship assumptions. Okay, so linear ba yung yung relationship ni ni hourly wage at saka ni education? Kasi dapat linear sila, di ba? Kung hindi guys, hindi magiging maganda yung model natin. So here, ang lumalabas dito, yung red line na to dapat as much as possible linear to. But here, parang hindi siya linear, ano? Okay, parang hindi siya linear. Tapos dito may nakalagay na 15, 186, 112. These are influential points. Ano yung influential points? It's different from outliers. Okay? Ang outliers, di ba, we can show that via the bar plot. Di ba, yung nasa labas ng whisker natin. Okay? Ang outliers, guys, okay, it's not the same as influential points. An influential point is one that can, when you remove it, it can affect the regression results. Pwedeng magbago ng malaki yung regression output natin. Yun ang influential. So all influential points are outliers. But not all outliers are influential points. Okay, ulitin ko yun. All influential points are outliers, but not all outliers are influential points. So there's a way to compute the Cook's distance. Pwede nyo i-check na lang sa internet kung ano yung computation niya, but we will not go into the computation. But it can be easily determined. So pag rinan natin to, this is what we get. So sabi natin yung residuals on the y-axis, predicted values on the x-axis, it will tell us kung linear ba yung relationship ng dependent at saka independent variable natin. Turns out that mukhang barely linear siya, no? So, hindi siya gaanong linear. Okay. So second plot, guys, yung QQ plot, it will tell us of the normality of your residuals. Okay, so dito yung pinaplot natin, dito yung standardized residuals. Okay, and then dapat, guys, dapat yung plot na to, dapat malapit sa straight line na to. And then you can see here that it doesn't show that the residuals are normally distributed. So may problem tayo dun sa ano natin, sa residuals natin, kasi it does not follow the straight line. No? Dito medyo nag-curve na siya dito. Okay. However, guys, resolving this is not in the province of the subject. I-discuss niyo pagdating niyo sa next subject. Okay, and then ito naman yung number 3 to. If you run this, number 3. Okay, so this is now your scale location, and it will tell us of the homogeneity ng variant ng yung constant variance ng mga residuals natin. And medyo medyo parang hindi siya talaga ganun ka-constant. Kasi if you take a look at if you take a look at the residuals, may fanning out siya. Notice, guys, over the greater fitted values, lumalaki yung variance natin. Okay, napansin niyo parang nagfa-fan out siya. Okay, dito medyo okay lang, no? Pero pagdating sa higher values ng fitted values natin, okay, lumalaki na yung ano natin, lumalaki yung residuals, standardized residuals. And that's indicative of heteroscedastic residuals, heteroscedastic error terms. Okay, and then number 4, ito yung residuals versus leverage. Ganun din binibigyan nito, guys. So this number 5 here is actually the 4th plot in the plot above. Yung 1 to 4, no? So kita natin, guys, here. Andito na naman si influential points. Very consistent na lumalabas sila. Okay? Again, dapat straight line to, guys. So this is indicative of okay, anong indicative of influential cases, no? Dun sa plot natin. And lastly, influential points then, guys, ito, mod 1, number 4, Cook's distance. So we have seen this a while ago already, 59, 112, and 379. So, as sinasabi dito, investigahan yung data points na yan. Okay, baka nagkamali. Kung nagkamali, pwede natin tanggalin. Kung hindi, guys, then baka hindi pa pwedeng tanggalin. So, there are some things that may be done in order to address this. Okay? Or, also, baka hindi enough, hindi tama yung linear model natin na ginagamit. So, maraming pwedeng tingnan dyan, ano? Okay. So, let's now go to multiple regression. Ang multiple regression natin, guys, di ba? You have several variables and then one continuous dependent variable. Let's take a look again at our wage data set. Dito may problem tayo kasi may mga categorical variable tayo. Okay? Pwede itong gamitin kaso this has to be converted. Okay? So ang gagawin natin dito, magmo-multiple regression tayo. We're going to model hourly wage and then we're going to use all of these variables as predictors. So in R, what we have to do is to convert muna yung mga character variables yan into factors. Okay, tingnan sandali natin to, no? Okay, sa race, guys, sa race, ilang levels ng race? Dalawa, white at saka non-white. Okay, alphabetically, sino yung unang lalabas? Sino yung number 1? Yung non-white, no? Yung non-white yung mauuna alphabetically. So, kung sino yung mauuna alphabetically, guys, yan yung uuna, yan ang gagawing benchmark. Ibig sabihin, papalitan kasi to, no? Papalitan to ng 0 or 1. So, si non-white gagawing 0 yan. That will be the benchmark. Si white yung gagawing 1. Okay. We need to know that kasi pag in-interpret na natin, dapat alam natin yung benchmark, dapat alam natin yung reference variable natin. Si R, ang ginagawa niya, yung alphabetically na mauuna, yun ang ginagawa niyang benchmark or reference variable. Sa ibang softwares, iba, no? However, kung gusto mo rin na medyo ang gawing benchmark si white, pwede rin yun. That can be done also in R. Sa gender, sino yung reference natin? Sino yung benchmark natin? Paki-chat nga, guys. Sino yung magiging reference variable natin sa gender? Anyone? Female, correct. Thank you, Jerome. Thank you, Juanito. Thank you, James pala. Thank you, Juanito. You're correct. It's female. Bakit si female? Kasi, dadalawa lang naman din levels natin, female at saka male. And since female appears alphabetically first. Ito guys, hindi alphabetical yan, ha? Okay? So, random tong arrangement na to. So, kahit mauna si male o si female, ang gagawin pa ring benchmark si female kasi siya yung una alphabetically. Okay? So, ano ibig sabihin ng gagawin siyang benchmark? Gagawin siyang 0, ang gagawin si male 1. So, what happens, guys, behind the scene is that pinapalitan to pinapalitan sila ng number, no? 0 and 1. Ganun din si civil status, si married gagawing 0, si single 1. Okay, so yun lang yung tatlong categorical natin, guys. So ginagawa natin silang factor. No? Kung ano yan, guys, kung kunyari, year level sa college, no? So apat yung possible na levels natin, frosh, sophomore, junior, and senior. Ang gagawin doon, guys, ang 0 doon si frosh kasi nga alphabetical. And then tatlo yung ano natin, tatlo yung ibang variables natin, si sophomore, si junior, at saka si senior. Okay? So ang mangyayari niyan, guys, tatlong iba't ibang variables. Okay? 4 yung levels minus 1 kasi hindi na natin ipapakita doon si frosh. Ang ipapakita lang doon sa mga columns, 1 column for sophomore, 1 column for junior, 1 column for senior. So that's what happens. No? So ibig sabihin yung ibang levels nagiging independent variable din sila. So how many independent variables, guys? N minus 1. Ano yung N? Yung number of levels. So kung ang isang factor, guys, kung ang isang categorical variable na ginawang factor, 6 yung levels siya, ibig sabihin nun, 5 yung bagong variables na ipapasok. Okay? 5. Ba't 5 lang? Kasi tatanggalin na yung gagawing benchmark na yung gagawing 0 sa R, which in R is the first alphabetically. Okay, so balikan natin tong gagawin natin. So, we're now going to do model 2 ang itatawag natin sa kanya. No? Take note, LM, hourly wage yung dependent variable, tilde, then i-identify natin yung 7 dependent variable natin. Independent, sorry. So, education, experience, tenure, race, gender, civil status, number of dependents. Data is equal to wage. Another way to put it is mod 2 is equal to LM, hourly wage, tilde, dot. No? Ibig sabihin ng dot dito, lahat ng mga independent variables. Okay, so pareho lang yan. No? So let's, tanggalin na natin tong ano dito, guys. Tanggalin natin tong parenthesis para hindi na niya i-generate yung coefficients lang. And then let's run this model 2. There. Okay? So meron tayong output ni model 2. Okay, so kinocall yung formula, HR wage, regressed on all the variables. No? Data is equal to wage. Then here we have the measures of the residuals. And then we have now here the independent t-test. Okay. Okay, sandali Medyo ulitin ko yung pag-run kasi hindi kumasya. Okay, let me rerun this, guys. Para kumasya yung ano. Okay, yan, kumasya na siya. Kanina kasi nabitin yung asterisk. Alright, let's go first to the overall goodness of fit test. Diba? Ito, guys, yung FSTAT. Overall goodness of fit test. FSTAT is 43.54. Degree of freedom 1 is equal to 7. Bakit 7? 7 regressors tayo, excluding yung intercept. Bakit degree of freedom is 518? Because n minus k minus 1, n is 526, k is 7, and then minus 1, that's 518 degrees of freedom. P-value, maliit pa rin, no? Less than 0.05. Okay, so what's our null hypothesis here? Ang null hypothesis natin is ito. Null hypothesis beta null is equal to beta 1 is equal to beta 2 hanggang is equal to beta 7 is equal to 0. Okay, so ang ano natin dyan, ang conclusion natin, we reject the null hypothesis that beta null is equal to beta 1 hanggang is equal to beta 7 is equal to 0. We have strong reason to believe that, we have strong statistical reason to believe that at least one of these parameters is not equal to 0. Okay? So hindi natin sinasabi na lahat sila not equal to 0. Ang sinasabi lang natin, at least one of them is not equal to 0. Kasi combined, joint yung ano, guys, yung null hypothesis, di ba? Okay, so yun ang sinasabi natin. So okay yung model natin, overall goodness of fit. May mga predictors tayo na pwedeng i-explain si hourly wage. Multiple R squared, guys, ano nangyari? 3704. adjusted R squared 3619. Sabi natin guys, si adjusted R squared is lower than your multiple R squared. Kasi we might be tempted to, sabi natin, di ba, isang benchmark for measuring the goodness of the model is R squared. So the higher the R squared, the higher is the capability of the model to explain your dependent variable. Kaso may caveat yun, may warning. Kasi baka pwedeng dagdag tayo ng dagdag ng the independent variable, which the effect is, tataas talaga yung adjusted R squared. Pero baka naman wala nang kinalaman yung variable na sinasama natin dun sa model. So yung adjusted R squared is sort of like a penalty for adding more maybe unnecessary variables. So kapag multiple regression, guys, ang kino-compare natin yung adjusted R squared as compared to the multiple R squared. So ito yung tinitingnan natin, adjusted R squared, when we're comparing, when we're dealing with multiple linear regression and comparing models, no? Okay, so tingnan natin dito, guys, yung independent, yung individual t-test natin. Okay, sino lang yung mga ano dito? Sino lang yung mga significant? Okay, yung may mga asterisk at saka itong dot, ano ibig sabihin nito? Yung dot, guys, this is significant at 10% level. Tingnan nyo, guys, yung Pini experience, 0.07. So hindi siya significant at 5% kasi greater than siya ng 5%. But it is significant at 10%, kaya nga may dot dito. The other two, si civil status at saka si NAMDEP, hindi siya significant, no? 0.12 at saka 0.17. Okay, let's interpret this. Okay, una muna, itong mga categorical variables natin. Okay, factors natin. Tingnan nyo, guys, oh, yung variable natin naging race white, gender male, civil status single. Ang ibig sabihin nito, guys, ito yung value ng white, no? So remember kanina, sabi natin, sa race, sinong gagawing benchmark? Si non-white, kasi una siya alphabetically. So when we interpret this, guys, importante mamaya, it should be taken in the context of the benchmark variable. Ang benchmark variable natin kay race, si non-white. Ang benchmark variable natin kay gender is female. So when we interpret this, it's always interpreted in the light of your benchmark variable. Ganon din si civil status single. This should be interpreted in the light of your benchmark variable, which is married. Okay? So sige, tingnan na natin to isa-isa. Ano ibig sabihin ng education? What does education mean? It's statistically significant, di ba? Ibig sabihin ng education, for every 1 year increase in education, there's a corresponding 0.57 dollars, no? Hourly wage, increase in hourly wage. Okay? Nadagdagan ka ng isang taon ng education, madadagdagan yung hourly wage mo ng 0.57. And that's statistically significant. Okay? How about si experience? Experience, barely significant, no? It's significant at 10%. Okay, so assuming we're using the 10% confidence significant level, then this becomes significant, no? Kasi 10% yung ginagamit natin. Ano ibig sabihin ng 0.02? What's the meaning of 0.02? It means that for every year of year increase in experience, there's a corresponding $0.02 in average increase in hourly wage. Okay, so 2 cents ang increase dun sa hourly wage for 1 year increase in experience. Okay, nakalimutan ko sabihin, guys, 0.57 for every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage, comma, dito natin ipapasok yung ceteris paribus. Okay, I don't know kung na-discuss ko na sa inyo yan. Lagi yung sasabihin na ceteris paribus. Pag ini-interpret nyo na yung parameters, hindi yung ano hindi yung not necessarily the intercept. No? Okay. So ano ibig sabihin ng ceteris paribus? All things being held constant. Kasi kung tingnan natin to, guys, no, yung wage. Di ba predict natin yung hourly wage based on these variables? Sabi natin, pag nag-increase si education ng isang taon, may corresponding na $0.57 increase in hourly wage. Ceteris paribus. Ibig sabihin nun, dapat wag babaguhin sa experience, tenure, race, gender, civil status, number of dependents. Wag natin silang gagalawin. For this respondent, ang mangyayari, dadagdagan natin ng isa yung education, di ba? So magiging +1 yan. And then si experience 2 pa rin, si tenure 0, race white pa rin, female single, number of dependents 2 pa rin. Hindi natin sila babaguhin. Ang babaguhin lang sa education, dadagdagan natin ng isa. No? Kaya nga, ang pagbasa natin kanina, for every 1 unit, every 1 year increase in education, there's a corresponding $0.57 okay, average increase in hourly wage. And then comma, ceteris paribus. Huwag natin kakalimutan yung ceteris paribus. Okay, how about education? For every 1 year increase in education, there is a corresponding $0.02 increase in hourly wage, comma, ceteris paribus. Okay, ganun din si tenure, guys. Si race white, okay, how do we now interpret this? Okay, paano natin i-interpret si race white? Okay, positive siya. So assuming this is significant, hindi kasi siya significant, no? Race white. Ang ibig sabihin nito, for every, okay, anong ibig sabihin? On the average, white people receive 10 or 11, $0.11 more than their non-white counterparts. No? Ceteris paribus. Clear, guys? So ito, ini-interpret natin, bine-benchmark natin against yung benchmark variable natin, which is non-white. So again, binasa natin to. On the average, white people tend to receive $0.11 more than their non-white competitors. Ceteris paribus. Okay? So, notice na sinama natin sa pag-interpret, kinompare natin si white with non-white. Okay, itong male. Male respondents on the average receive $1.76 more in terms of hourly wage compared to their female counterparts. So, kino-compare natin. Mas mataas si male ng 1.76 compared to their female counterparts. Okay? Ceteris paribus. Si single, ganun din, guys. So single people tend to receive $0.46 less than their married counterparts. So mas maliit yung nare-receive ni single kaysa kay married. Okay? Ceteris paribus din. Okay, unfortunately, this is not significant, no? So hindi sasama sa model natin yan. Yung NAMDEP naman, guys, hindi rin siya significant, pero if it was significant, how will we interpret this? Every one unit or one child increase in number of dependents, tumataas daw yung hourly wage ng individual, no? Ng 0.146 ceteris paribus. Okay? Pause muna ako. Any questions, guys? Paki-chat nga kung so far clear tayo.
Sir, question. I don't understand the parentheses.
Kindly
Like,
please,
what do they
paki-chat kung
mean?
clear yung ano natin,
Sir,
clear yung
can you hear
explanation.
me?
Sir, someone's asking a question po. Hello?
Saan na yung ano dito? Ayan. Ay, may nagtatanong. Ay, sorry ah. Hindi ko marinig.
Sir, someone's asking
Ay,
po.
sorry. Hindi ko marinig kanina. Oh, sige. What's your question?
Sir,
Sino ba? Who's asking a question?
me, sir.
Sige. Sino to?
Juanito, sir.
Juanito, sige. What's your question?
Sir, I don't understand the asterisk and what do those mean?
Okay, sige. Thank you for the question, Juanito. No? Itong asterisk dito, guys, sinasabi nito kung significant yung predictor natin. Okay, tinan nyo to, tatlong asterisk. If you take a look at the bottom portion, significant codes, tatlong asterisk, ibig sabihin, significant siya at 0.001. Ang ibig sabihin nun, yung p-value natin is less than 0.001. No? Okay. So ito din, less than 0.001, kaya tatlong asterisk to. No? Kunyari, meron tayong ditong 0.03. No? Kunyari lang if we have here a, let's say a p-value, p niyan is equal to 0.03. Okay. Ilang asterisk ang makikita natin dyan? Ang makikita natin na asterisk dito, isa lang. Ito. Okay? Hindi dalawa kasi it's greater than 0.01 eh. So we will only see 1 star. Pero statistically significant pa rin kahit 1 star yan kasi ang benchmark natin 0.05. No? Itong dot na to, tingnan nyo guys, dot, 0.1 siya. Bakit hindi siya 1 star? Kasi it's greater than 0.05. But less than 0.1. Okay, 0.07 is less than 0.1. So this tells us that experience is statistically significant if the level of significance being used is 10%. Pero kung ang level of significance 0.05, hindi siya significant, no? Okay, so it's up to the one conducting this test kung gagawin niyang significance experience or not. Okay? Juanito, did that answer your question?
Yes, sir. Thank you, sir.
Sige, clear na. Okay, so guys, yun ang ibig sabihin ng ano. So dito makikita nyo kung significant yung mga predictors natin. So si race white is not significant. Tingnan nyo, 0.797. Okay? Mas malaki nga siya kaysa kahit 0.1 eh. Ganon din si civil status and si number of dependents. Okay? So, ang importante dito guys, yung ano well, importante lahat pero more yung factors natin on how it is interpreted. Positive guys means mas malaki itong kung sino man yung 1 dito compared to the 0. Race white, ibig sabihin, white is number 1, si non-white is 0. So pag in-interpret natin to, si white receives $0.11 more than their non-white counterparts, ceteris paribus. Male receives $1.76 more than their female counterparts in terms of hourly wage, ceteris paribus. So ang question dyan, may discrimination ba na nangyayari? Okay, so that's a very good topic to discuss also, and that can be done by adding what we call an interaction variable. Pero i-discuss nyo yung pagpunta nyo na sa FINSTAD. Okay, ito naman guys, ano ibig sabihin ng negative 0.45? Okay, si single receives $0.46 less kasi negative siya than their married counterparts in terms of hourly wage, ceteris paribus. That would have been the interpretation kung significant siya. Kaso hindi siya significant. So ang ibig sabihin, possibly, na ang value nito is 0. No? So very possible na ang value nito is 0. So yung mga hindi significant guys, ang ibig sabihin yan, na itong estimate na to, possibly, is equal to 0 yan. No? That could be equal to 0. Okay? All right, so let's move on, guys. Let's move on. Okay. Now, dalawa yung model natin, di ba? Model 1 at saka model 2. Okay, kung titingnan natin, let's take a look at AIC and BIC. Una muna, guys, yung R squared, no? So let me write it here. Okay. Summary. Okay. Summary. Capital. Summary ng mod 1, okay, and dollar r dot square. Okay. And then dito, summary mod 2 and dollar r dot square. Okay, compare natin guys si model 1. Si model 1 yung simple regression lang. Si model 2, ito na yung multiple regression. Compare natin yung dalawa, run natin. Okay, tingnan natin guys. Si model 1, ang kaya niyang i-explain 16.5% lang. Diba? Ito yung diniscuss natin kanina. Isang predictor lang to sa education. On the other hand, ito, si Model 2, where we are using seven independent variables, 37% na yung ano niya, yung coefficient of determination, yung R squared. So based on this, sino mas magandang model? Paki-chat nga guys. Based on that, which model is the better model? Okay, please paki-chat.
Second one, sir.
Yeah, second one. Thank you. Thank you, Juanito. It's the second one. Kasi mas mataas yung R squared natin, no? In fact, ang tinitingnan natin dapat yung adjusted R squared. This is the R squared lang. Pero whether we're comparing the adjusted R squared, di hamak na mas mataas si Model 2. So ibig sabihin, nakatulong yung pagdagdag natin ng mga predictors. Kasi sa Model 1, isa lang yung predictor na ginamit natin. Sa Model 2, kahit na ang gamitin natin adjusted R squared, mas magaling pa rin si Model 2. Okay? So what about using ito, AIC, BIC? Tingnan naman natin dito, guys. Let's run this. If we're going to use AIC, si Model 1, 277, yung akaiki natin, si Model 2, 2640. So ang rule dyan, guys, the lower the akaiki, AIC, the better the model is. So ganun din sa BIC, 2790, 2679, mas mababa si BIC, therefore, mas maganda si Model 2. Okay? So based on R squared and based on AIC, BIC, mas maganda si Model 2. However, guys, kailangan i-test natin siya. Dapat may statistical test tayo doon. Ano yung statistical test natin? Ito. ANOVA. Mag-a-analysis of variance tayo. Okay? So before we do that, si Stargazer, guys, yung package na to, it can give us, no, a very beautiful report, no, comparing yung Model 1 natin at saka Model 2. Yan. So it gives us a tabular form, Model 1, Model 2. Ayan, 526 observations. R squared natin, 16% lang dito 37%. Okay? So adjusted R squared natin, mas maganda talaga si Model 2. Okay? So here you can see yung summary ng Model 1 natin at saka Model 2. And as we said, guys, mas maganda si Model 2 based on adjusted R squared and AIC and BIC. Okay. Okay. However, guys, asan yan? Okay. Ano ko lang to? Exit. Okay, we have to do a, kailangan mag-ano tayo, guys, mag-ANOVA, no? Mag-ANOVA tayo. Okay, so dito may sinulat ako dito. Okay. So ito, compare Model 1, yung simple linear regression natin, at saka Model 2, yung multiple linear regression. Okay. Ang Model 1 natin, guys, yung mas konti yung predictors, yung isa lang, no? Education lang ginamit natin doon. Ang tawag natin doon, restricted model. Restricted kasi mas konti yung predictors siya. Model number 2 is your unrestricted. So take note, kino-compare natin yung dalawa, no? Between the two, ang Model 1 yung restricted, Model 2 is unrestricted. Kasi more predictor siya. Okay, magta-test tayo ng ANOVA, analysis of variance. Ang null hypothesis natin, the restricted model is preferred to the unrestricted. Mas maganda daw yung restricted natin, yung mas konting variables compared to the unrestricted. Bali, ang sinasabi natin, kailangan pa bang idagdag yung ibang variables? Baka pwede na lang na isa lang, na si education lang. The reason behind that, guys, is if we can describe, if we can explain the dependent variable using lesser variables, mas maganda yun. No? Imagine, guys, take note. Kunyari, meron kang model na ang ginagamit mong independent variables, 4 o 5. Compare that to one with 100 independent variables. Oh, guys? Sinong mas madaling i-explain? Yung 100 independent variables, aside from being difficult to explain, difficult to do an analysis on, mahal yun, guys. Imagine, pag magre-research ka, tas 100 variables yung yung tinitinan, buti sana kung isa lang panggagalingan yan, no? So that can be very expensive. And besides, that can be very time-consuming. So kung pwedeng restricted model, mas maganda yon, no? But we have to test that. So is it reasonable to add? Naging 7 na, di ba? Sa model 2, naging 7 na yung variables natin. Reasonable to do that ba? Oh, well, makikita natin by using ANOVA, no? So dito ANOVA, guys, let's run this ANOVA. Okay, so ito yung ANOVA natin. Okay, ito yung titingnan lang natin dito. Ito. Okay, so si model 1, isa lang yung regressor. Si model 2, yung maraming regressors, yung 7. Sabi dito, the p-value, the f-stat is 28.202, and then the p-value is 3 stars, ibig sabihin less than 0.001. So ano to, guys? Reject or fail to reject? Paki-chat or pakisagot, guys. Anong conclusion natin? Reject or fail to reject? Guys, paki-unmute na lang para mabilis tayo. Answer, guys. Hello? Anyone? Anong conclusion natin? Reject or nung null hypothesis, are we going to reject it or do we fail to reject the null hypothesis? Answer, please. Look at the p-value. P-value is, it's less than 0.001. Diba? So kung less than 0.001, ang ginagamit natin 0.05. Less than 0.05 siya. Therefore, diba, when the P is low, the null must go. Therefore, guys, reject.
So reject null.
Correct. Thank you. Thank you. Reject the null hypothesis. Okay? So pag rineject natin si null hypothesis, balik tayo. Ano ba yung null hypothesis natin? The restricted model is better. So rejected natin yon. So sino mas maganda, guys? Si model 1 o si model 2?
Model
Model 1 or model 2 mas maganda? Come on, guys. Come on. Sino mas maganda, guys? Model 1 or model 2? The restricted or the unrestricted?
Model 2, sir.
Hello?
Model 2 po.
Model?
2.
Yeah, correct. Model 2. No? Kasi tingnan yung null hypothesis, guys. Ang null hypothesis natin, restricted model is better. P-value natin, less than 0.05. Therefore, i-reject natin si null hypothesis natin. Ang claim kasi natin, restricted model is better. Reject natin yon. Therefore, we're going to use the unrestricted model, si model number 2. Okay? So, asan si model number 2? Ito, di ba? In-explain na natin to. Right? We already explained this. So, anong susunod na gagawin natin? Tapos na ba, guys? Hindi. Explain muna natin yung model natin. So, this will now be our model. No? Okay, hindi ko ba sinulat? Okay. Ba't hindi ko sinulat dito? Bakit wala siya dito? No? Okay. Anyway, how will our model look like? It will be negative 3.3895. Dala? Baka andito. So I think I wrote that. Hindi pala, sorry. Sorry, I didn't write it. No? Pero if you are asked, guys, if model 2 yung pipiliin natin, ano yung model natin? Negative 3. Hourly wage is equal to negative 3.39 plus 0.57. Tapos let's say we include experience, 0.57 times education plus 0.02 times experience plus 1.38 times 0.138 times tenure, hindi kasama si race white, times 1.76 times gender, okay? Tapos, yun na. So, hindi kasama yung mga insignificant variables. That will be our model. Okay. So, pero tama ba yun, guys? Yun na yung final model natin? Hindi. Kasi ilan ba yung insignificant natin? Ang insignificant natin, kasama yung, kung isasama natin si experience, guys, 4, no? Okay, so we do what we call a stepwise regression. Ang tawag natin dyan, guys, stepwise regression. Ano yung stepwise regression? Stepwise regression. Ang stepwise regression, guys, this is used in determining what will be the final model. Okay, dalawang klaseng stepwise. Okay, we have what we call the forward at backward. Okay? Ang gagamitin natin, guys, si backward stepwise regression kasi mas madali siyang gawin. No? So si backward stepwise regression, ang ginagawa natin dyan, sinasama natin lahat ng variables tapos iisa-isahin natin tatanggalin one by one yung mga hindi significant. So ibig sabihin, guys, magtatanggal tayo dito ng isa. Ano yung tatanggalin natin? Ang tatanggalin natin, guys, among the insignificant ones will be the one with the lowest t-value, absolute value. No? In other words, tanggalin yung mga negative dito. Ang candidate lang naman natin itong, kung isasama natin itong si experience na significant at 10%, okay, 1.78, ito 0.25, ito 1.56, ito 1.34. Okay? Excluding the negative sign, guys, ang tinitin lang natin yung t-value, absolute ng t-value. Ang pinakamaliit si 0.257. Therefore, ito yung tatanggalin natin. Okay? So therefore, guys, magmamodel naman tayo na wala na si race. This will be called your leaving, L-E-A-V-I-N-G, leaving variable. Okay, so let's go down, guys. Let's go down here. Punta na tayo sa model number 3. Okay, so si model number 3 natin, ang bilis ng oras, grabe. Model number 3 tayo, guys, ito. Okay, so model 3, LM natin, hourly wage, okay? Sa taas, education plus experience, tenure, gender, civil status. Tinanggal natin si race, di ba? So, 6 na lang to. 1, 2, 3, 4, 5, 6. 6 na lang kasi tinanggal natin yung pampito na si race. Paano natin pinili si race? Siya yung pinakamaliit na T stat, absolute value. Okay? So, another way to write this is HR wage tilde dot yung lahat, minus race. Tinanggalan natin si race. So, sige, i-run natin to. I-run na lang natin tong nasa baba. No? Okay? And when you run this, you'll have this. So, hindi ko na i-run kasi na-run ko na to. Okay, so this is now model number 3. No? Okay, take note, guys, na meron pa rin insignificant. No? So hindi ko na i-discuss, guys, yung meaning na to. You know how to interpret this already. No? Okay, and we have si experience still, significant pa rin siya at 10%, pero yung dalawa, hindi significant. Okay, so if we're going to, we can now compare. No? Okay, bago tayo magsusunod na model, tingnan muna natin kung mas okay ba si model 3 kaysa kay model 2. Okay, so ganun din, guys. Ito, based on AIC and BIC, lumalabas na mas maganda si model number 3, 2638, 2672 compared to that of model number 2. Ganun din, if you compute for the R squared, mas mataas yung adjusted R squared ni model number 3. But, kailangan natin, guys, gamitin si ANOVA. Okay? Ano ba yung null hypothesis natin dito? Ang null hypothesis natin is that the restricted model, okay, sino yung restricted natin? Model 2 or model number 3? Ang restricted model natin si model number 3 kasi ito yung tinanggalan natin ng race. No? Ito yung 6 lang yung regressors natin. Si model number 2, 7. So sabi natin, yung null hypothesis natin dito sa analysis of variance, kapag nagko-compare na tayo ng model, is the restricted model is the better model. So ang tinitingnan natin, mas okay ba si model number 3? Kasi si model number 3, 6 lang yung predictors natin. Si model number 2, 6. So, does it, 7 pala, sorry, 7, si model number 2. Does it make sense to add one more kay model number 2? Okay, let's see. No? So when we run this, guys, ano makukuha natin? Rina natin yung ANOVA na yan, ito lumabas. So model 2, model 3 ang lumabas. P-value is 0.7971. Okay, not significant. Okay, so we fail to reject the null hypothesis. Hindi natin mare-reject to. So sino mas maganda? Si restricted model ang mas maganda, si model number 3. Okay? So there is now an improvement, guys. Sabi natin, using 6 independent variables compared to 7, mas maganda. Okay? Mas maganda. Kasi lumalabas na si race, hindi siya significant predictor. So ba't pa natin siya isasama sa model natin? Okay, guys? Okay, then, punta na tayo ngayon sa ano yung living variable natin. Next model, tatanggalin natin, guys, si number of dependents. Kasi 1.33 to, ito 1.5. Remember, disregard the negative sign. Mas maliit si number of dependents. No? So since maliit si number of dependents, yun ang tatanggalin natin dito. So hourly wage, regression, education, experience, tenure, race, gender, civil status. 1, 2, 3, 4, 5. Oops, dali. Ay, ito pala. Up, mali. Sorry Ito. Model 2 and model 3. Ay, sorry. Model 3 na tayo. Saan si model 3? Ito, guys. We're now doing model 3. Okay. LM ng hourly wage, education, experience, tenure. So, tinanggal natin si. Okay, mali ito. Dapat walang, ano to. Tanggal na to, guys. Sorry Tanggal na to. Model 3 na to, di ba? Ay, wait. Control Z. Hindi, ang model 4 na pala tayo, sorry. Model 3 yung kanina eh. Okay, tapos sa itong model 3 and 4. Model 3 and 2. So now we go to model number 4. Okay. Ito na si model number 4, guys. So tinanggal natin dito si number of dependents. So ilan na lang siya? 1, 2, 3, 4, 5. 5 na lang, no? Kanina 7, binawasan ng isa, naging 6. Tapos ngayon, binawasan ulit ng isa. Tinanggal na natin kanina si race, tapos tinanggal din natin si numdep, no? So 5 na lang to. So again, guys, let me remove the parentheses here para hindi na mag-ano yung coefficients. Okay, if we run this, we're going to get this. Ito yung model natin. So this is model number 4. Okay, so if you take a look, guys, no? Okay, si experience naging ano na, no? Si experience naging not significant na. Si civil status significant pa rin kaso at 10%. Okay. All right? So this is not model number 4, no? So before we go to the next step, i-compare muna natin. Sino ba mas maganda, si model number 4 o si model number 3? Notice hindi na natin kino-compare kay model number 2 kasi si model number 3 mas maganda kaysa kay model number 2. So bakit pa tayo babalik dun sa model number 2? So what we're comparing now is 3 and 4, no? And this is what we call the stepwise, backward stepwise regression. Step by step natin ginagawa. Backward siya kasi dinalagay muna natin lahat ng mga variables tapos isa-isa natin siyang tinatanggal. Okay, so let's check, guys. Let's perform ANOVA. Okay, didiretso na ako dito ANOVA, model 4, model 3. No? So this is what we get. Okay, analysis of variance ni model number 3. Model number 4 is education, experience, tenure, gender, civil status, 5. Model number 4 versus model number 3. No? Ito yung 6. Okay, it turns out that the p-value is 0.184. Therefore, we failed to reject the null hypothesis. Okay? We failed to reject the null hypothesis. So mas maganda si model number 4 kaysa kay model number 3. Model 4 is better. Okay, so may matatanggal pa ba tayo? Since na kay model 4 tayo, balikan natin si model number 4. Okay, si model number 4 guys, which is this one. Okay, so ito isa na lang yung not significant, no? Isa at 10%, pero mas mababa si mas mababa si experience. So notice yung kanina, si experience kasama. Diba? So anong nangyari dito, si experience ngayon hindi nakasama, no? So that's why it's important to do this step by step lang, no? Kasi minsan yung variable na significant nagiging hindi siya significant, no? So anong tatanggalin natin? Experience. Okay, so experience ang tatanggalin natin one at a time, okay? So let's remove experience now. Let's now create our model number 5. So ito na yung si model number 5 natin. So this is our model number 5. Tinanggal natin si experience. So education, tenure, gender, civil status. Wala na si experience. Okay? So summary natin si model number 5. Okay, run natin to. Run. Okay, we have this, guys. Yan. What do you notice about our predictors? Okay, anyone, guys? What do you notice about our predictors? Somebody, please. Ano na-notice natin sa predictors natin?
The civil status became an asterisk.
So, significant siya, di ba? Ito yung significant at 5%, di ba? Right? Pero lahat na sila significant. Okay? So, yung intercept, it doesn't matter, guys, kung significant siya o hindi. Basta ipapasok pa rin natin sa model yan. So, lahat ng independent variables natin, significant na. So, ano ibig sabihin yan? Final model na yan. Kasi wala na tayong living variable. Wala na tayong matatanggal. Yan na yung pinaka-ano na model natin. Okay, let's test. Test muna natin kay ANOVA. Hindi tayo nag-ANOVA dito, no? Okay, test ko muna yung ANOVA nito. Okay. Insert. Okay, ANOVA. ANOVA between model 5 and model 4. Let's just check, no? Okay, para ma-verify natin. ANOVA, model 5, model 4, oops. Mali ito, MOD. Oops, small m. Mag-e-error yan kung malaki. No? Ay, maka-capital pala to. Sorry. ANOVA. Okay. Enter. Oh, ANOVA. Model 4? Basta yung model 4, di ba? Bakit wala akong model 4? Hindi ko rin si model 4. Sorry, ha. So, i-run ko muna si model number 4. Sorry. Okay. Hindi ko pala rinan to. Kasi may output na eh. Okay, I run model number 4. Okay, so my model 4 na. Okay, since we already have model number 4, I can now run our ANOVA. ANOVA, ito. Let me run this. There. Okay. P-value 0.1198. Okay. Ano conclusion natin? We failed to reject the null hypothesis. Ano null hypothesis natin? Model 5 being the restricted value is the better model. Model 4, ito yung unrestricted si model 4 kasi mas marami siyang predictors. Ito 5, si model number 4. Si model number 5, 4 lang. Therefore, ang conclusion natin, mas maganda si model number 5 compared to model number 4. Okay, since si model number 5 is better and wala na tayong matatanggal sa model 5 natin, ito na yung final model natin. Okay, so that will now be our final model. Tapos, ito guys, ito yung equation niya. So this is the equation for our final model. Hourly wage is equal to negative 2.136 plus, okay, ito na yung mga parameters natin ito na yung parameters natin ng model natin. So this one. Okay. That one, guys. Okay, sana yun? Ito, no? Ito yung mga parameters natin. So if we're going to evaluate this, ano ibig sabihin nito? Okay. I'm sorry, I forgot something. Balikan sandali natin tong ano Balikan sandali natin to. Yung model 1 natin. May nakalimutan ako i-explain, no? Yung coefficient, hindi ko yata na-explain sa inyo kung ano ibig sabihin nun. Okay, si model number 1. Where is model number 1? And then model number 2 pala. Model number 2. Where's model number 2? Sorry. Okay, this one. Okay, this one, guys. How do we interpret intercept? Okay, so si intercept, guys, negative 3.39, sabi natin, that's the hourly wage. Okay, although wala siyang physical implication kasi wala naman talagang hourly wage na negative, no? Negative 3.39 is the hourly wage of a person with no years of education, no years of experience, no years of tenure, and no dependents, who is non-white, who is a female, or who is married. Okay, take note, guys. No, ang intercept, that's the value of the average value of your dependent variable hourly wage, if the independent variables are all equal to 0. So pag in-interpret natin to negative 3.38, guys, ibig sabihin nun, dapat kung 0 to, ibig sabihin non-white siya. Kung 0 to, guys, ibig sabihin female siya. Kung 0 to, ibig sabihin nun, guys, married siya. Okay, so this is the hourly wage of a person who has no years of education, no experience, no tenure, non-white siya, female siya, at saka married siya, at saka wala siyang dependents. Okay? Kuha, guys? So ano naman yung hourly wage daw ng isang tao na walang education, walang experience, walang tenure, walang dependents, pero white siya, male siya, at saka single siya. Ang mangyayari nun, guys, yung intercept plus, since white, male, single siya, di 1 to, di ba? So 1 times this one, 1 times this one, 1 times this one. I-add lang natin to mga to, added to this negative 3.389. So that's the interpretation. Okay? Guys, it's almost time. No? So ito, guys, inano ko lang yung equation. No? Ito na yung final equation natin. Okay? Based on the backward regression natin, stepwise regression, wala na tayong matatanggal. So this is just a statement. Ipapadala ko sa inyo to, no? This is just a statement about the output natin. I leave that to you to read. Okay? And then, i-plot nyo ulit, guys, itong mga residuals natin. Tingnan nyo kung ano ba siya, kung okay ba siya, kung heteroskedastic ba siya. Okay? And then, ito na, guys, yung stepwise regression. May I request you to please go through this. Okay? Tingnan nyo, guys, kasi ang stepwise regression using OLSRR, install nyo muna to. Kasi kanina, di ba, nag-manual tayo, inisa-isa natin. Okay? Pag ginamit natin si OLSRR, automatic yan, i-backward regression niya lahat, no? Stepwise regression, either backward or forward. Okay? So may I request you to go over this, guys. Okay? And then, bukas, dun sa kung a-attend kayo ng session ng 7:30 ng umaga, i-assume ko, guys, na naran nyo na to, so I'll just quickly go through this. And also the other file, yung diagnostics. No? So siguro first 1 hour, yun ang i-discuss ko, or first 45 minutes. And then magpo-pause muna tayo, punta tayo sa another para may ibang recording yung susunod na lesson natin. Okay. Now, yeah, sige. So any questions, guys? Any questions?
Sir, attendance po, sir.
No questions?
Okay.
Sir, what time is the quiz tomorrow?
Quiz tomorrow is 6 o'clock in the evening, ha?
Thank you, sir.
6 p.m.
Sir.
Mag-ano ko, magbibigay ako ng announcement ngayon para yung mga sinabi ko naka-record doon.
Same
Yes?
format as before, sir.
Yeah, oo. Ano lang to, at saka yung coverage will just be ggplot at saka dplyr. Yung mga natin, select, yung mga group by. Okay. All right? No more questions? Kung wala na, guys, thank you so much. Yung mga magpapacheck ng attendance, please remain. Sino magpapacheck ng attendance?
Ako po, sir.
Okay, sandali Iano ko lang yung attendance natin. The rest, guys, salamat.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, sir.
Thank you. I'll post yung video, guys. Siguro i-post ko na rin din yung sa isang section kasi baka may mga na-miss out ako kanina. So, kung okay lang sa inyo, tingnan nyo rin yung isang video. No? But halos pareho lang naman yan. Okay, thank you.
Pero sir, yung for tomorrow po, isa-send nyo rin po sa amin yung video.
Yeah, oo. I'll send the video. Yung recording bukas, no?
Thank you, sir.
Okay, sige. Thank you. Okay, sino magpapacheck ng attendance?
Me, sir.
Okay, sandali who's this?
Del Pilar.
Del Pilar, Miko.
Ano, sir?
Miko?
Yes.
Okay, sige. Thanks, Miko.
Thank you. Thank you, sir.
Alex? Okay. Sino pa?
Sir Gata.
Alex, no? Tama ba?
Okay na po, sir. Okay na po.
Okay,
Thank you.
sige. Thank you. Who else? Okay, wala na. Thank you.